Hello and welcome to another walkthrough on my channel. And today I am going to do a walkthrough of Physics Standard Level Paper 2, Time Zone 1, and that was conducted in November 2024. If you need any help with physics, or if you need personal tutoring sessions, or if you have some specific problems associated with physics, you can reach me out and I'll be very happy to help you. Okay, so question number one. In a loop-the-loop toy, a car of mass 0.12 kg is released from rest. The initial position of the car is 45 centimeter above ground. The radius of the circular loop is 15 centimeter. The car reaches the top of the loop at position P. Frictional and air-resistant forces are negligible. Show that the speed of the car at point P is 1.7. So you can see that when the toy car reaches here, it means it is at a height of 15 and 1530. Initially, it started with 45. So the car actually declined by 15 centimeter. Understand that? So we will say that loss of change in PE equals change in kinetic energy. Okay, so this is actually mgh and this is actually half mv square. From here, v is 2gh. You just need to do the calculations like the changes. Now, what is the change in mgh? The change in mgh is 2 into 9.8 into it was started from 45 or 0.45 centimeter. Okay, let me do that. The other side because we have less space in here. So V equals 2 into 9.8 into age was started from 0.5 and ended at 0.30, which is centimeter. So that is the change in potential energy, and it will be equal to the change in kinetic energy, and from here we will get the speed as 1.72 or equivalent to 2 meter per second. Determine the normal force exerted by the loop on the car at point P. Okay, so and determine the normal force exerted by the loop on the car. You know that the normal force is a contact force. For example, if this is a table and you have a book like placed on top of it, so your weight will be acting downward while the normal force acting upwards. Similarly, if you're coming down and climb a plane, it means the weight is acting down, but the normal force is acting this way. So normal is actually always at 90 degrees to the surface. Remember, if you are coming this way, then the normal is horizontal. So actually the normal depends on your location, and for the car moving in a circular path at point B, you can easily see that the normal force is actually acting down and the speed at this point is tangent to this point. Okay, so we will say that the car's weight and the normal are both in the same direction, and both of them together, like normal and the weight, are giving you the required centripetal force. So we will say Fc, which is the centripetal force, is actually obtained by the two forces. One of them is normal and the other one is the weight of the car. So N plus mg. And we know that we have to calculate normal force from here. So Fc minus mg. Now what is F? F is mv square over r. Okay, mv square over r minus mg, and we can need to see what is the mass. Mass is 0.12 and the speed of the car at point P is 1.7. You can see 1.7 and the mass is 0.12. So just put in the values. Mass is 0.12, right? Speed is 1.7, okay? Or to be precisely 1.72. Oh, no, no, no. It was 1.7. My apology. It was not equivalent to 2. It was actually equivalent to 1.7. It was mentioned here. So this is 1.72, and because it is our calculated value, and the radius is 0.15 minus 0.12 times 9.8. So calculating all of it, it will give you 1.2 newtons. State why the car stays in contact with the loop. So it looks like that the car at point P has to fall down, but it doesn't actually fall. It stays in the loop because the normal force and the weight are actually providing the required centripetal force. And what is the required centripetal force? It is the force which keeps the body moving in a circular path, because W and N together are providing necessary centripetal force. And centripetal force is the one which is required to move a body in a circular path. Okay. As soon as the centripetal force becomes limited or becomes less than required, the body slips away from the circular path. Just like you can see that when a high-speed car is taking a turn and it slips out because the required centripetal force is not enough to keep it in a circular path. But here in this case, the normal force and the weight of the object is providing enough centripetal force that the car is moving in a circular path. At point A, the car collides with a block of mass 0.18 kg and sticks to it. After the collision, the car and the block move together with speed of 1.2 meter per second. Calculate the speed of the car just before it collides with the block. It's very easy once again. So it started with 0 to 45 centimeter, and now it is ending at 0 centimeter. So what does it mean? All your kinetic potential energy, which was mgh, has been turned into kinetic energy at this point. Okay, so we will just write again, change in potential energy equals change in kinetic energy, mgh mv square. From here you will have 2gh under root, and since all of your height has been converted down to 0, you will just put in 2 into 9.8 into 45, or 0.45 minus 0. So from here, this is going to be equals to 3 meter per second. The surface from A to B is rough, and the combined car and block come to rest at B. Okay. The distance AB is 0.2. Determine the rate of change of momentum of the combined car and the block from A to B. Okay, now when you are moving along with this block from here to here, here you have the initial speed as 3 and here you have the final speed as 0. And in between you are having some acceleration and you are covering a distance of 0.2. Okay. So now they are asking you to find the rate of change of momentum. So first of all, you need to be a little bit vigilant here because rate of change of momentum has nothing to do with the SOVAT as we think, but it has actually a deep relationship. Let me show you how. First of all, here the the speed of the car is decelerating. I mean, it is decreasing. So it means there is a negative acceleration in here in this case. So we'll just write the final speed as v, initial speed as u, and in time t it all happening. Now if you open up the brackets, you will just see mv minus mu over t. Now mv is final momentum because it's final speed, and mu is initial momentum, which is initial speed. And when you combine them together, you will see that pf minus pi is actually change in momentum and change in time, right? So you can write that the rate of change of momentum is actually the applied force. So what you need to find out in order to find the rate of change of momentum? Here, they're asking you to find the rate of change of momentum. So all you need to do is just to find out the force. And how would you be able to find out the force? By just doing F equals ma, right? So first of all, using third SOHUAT, okay? If you use the third SOHUAT, using third SOHUAT, two as equals v square minus u square, right? So since your body's speed is decelerating, it is a negative acceleration, and final speed is 0 since your body comes to rest. All right. And yeah. And let me get my calculator to do the calculations. And initial speed is so actually the speed of the car was initially 3, but here the speed of the car is not 3. They are saying when the block and the car are moving together, their combined speed is 1.2. So we have to consider a speed of 1.2 here, okay? Be careful with that. So minus 2as equals minus u square, negative negative cancelled. From here you can get the acceleration as 1.2 square divided by 2 times 0.2, that is your total distance. And from here my acceleration is 3.6 meter per second square. Now finally I just need to do F equals ma, so their combined mass is 0.12 plus 0.18 times 3.6. So that is actually a rate of change of momentum, and it is equals to 1.1 Newton. Okay. Calculate the dynamic coefficient of friction between the rough surface and the combined car block. Okay, in the previous question, you calculated a force which stopped the car from A to B. It means that is actually your friction force. I can write the friction force is 1.1 Newton from the previous part, and we know for the dynamic coefficient of friction F equals mu R. And this R is actually equals to the normal reaction of the rough surface, right? And the normal reaction of the rough surface is equals to weight, which is equals to weight. And what is the weight? The weight is uh, the box and the car together times 9.8. Okay, so you just did it, and finally you get the dynamic friction coefficient as 0.37. Okay, since it is the ratio of the forces, on the left you have frictional force, and on the right you have weight, which is also force, Newton. So when you have the ratio of the both forces, you have a unitless quantity. There is no unit associated with a coefficient of dynamic friction. Okay, now question number 2. Outline by reference to Newton's third law how a gas in a container exerts pressure on container walls. Okay, so consider that this is your container. Okay, and consider that the molecule is coming and hitting it with this momentum mu. Okay, and this molecule is applying an action force towards wall, right? And upon hitting the surface of the wall will head back with the same force, but in opposite direction. Okay, so you will say that now the momentum is gone opposite, but it's actually the same, and there is a reactive force acting on the body as well. Okay, so that was action force, and that is reaction force. So action and reaction are equal in magnitude but opposite in direction. So from here we will say that initial momentum was mu, final momentum is minus mu. So what is the change in momentum? The change in momentum is actually initial momentum mu minus final momentum mu. Sorry, final momentum minus initial momentum, and you have a change in momentum as minus 2 mu. Got it? So that shows when you have a change in momentum, it means it will take some time to get this change in momentum. So force here is F equals delta P over delta T, which is equals to the rate of change of momentum. So it will be taken as 2 mu over delta T. So that is actually the force acted on on a molecule when it strikes the wall of the container, and that is how actually uh, how a gas in a container exerts pressure on the container. Okay. And when you have force here, you also have pressure from it. So when you have force here, you can also get the pressure. This is the pressure. Okay, by gas on container walls. Okay, state one difference between an ideal gas and a real gas. In ideal gas, you don't have no intermolecular forces. In ideal gas, but they are actually present in real gas. Two containers two containers of volume 0.2 and 0.1 are filled with an ideal gas. The pressure in the larger container is 3 into 10 to the power 4 pascals. The pressure in the small container is 9 into 10 to the power 4. The temperature of the gas in both containers is same. A thin tube with a wall joint the container. The wall is initially closed. Okay. The valve is opened so that the gas can move from one container to the other. Sorry. Sorry. The temperature remains unchanged. Determine the neutral pressure. Determine the new pressure of the gas. Okay. Right. We know that gas flows from high to low. From high P to low P, right? So it will we keep on flowing unless and until P becomes same on both sides. Okay. Look, okay, let me write within the box. Sorry. So you will say that one ball opens, gas moves, and it is always happening the same way. Gas moves from high P to low P unless and unless until the pressure becomes same on both sides. Okay. And flow stops. Flow stops. So now since they have mentioned that there is a different pressure on both sides, so you will say that the flow before should be equals to flow. Okay, never mind. Let's not going to do that. Just write a simple equation. And the simple equation is P1 V1. It's like this is your V1, this is your P1, this is your V2, this is your P2. All right. P1 V1 plus P2 V2 equals, when you open up the wall and there is a flow, it means the pressure now on both sides will be same, right? It will be same. So P V1 plus P V2. And you want to find P, that is the new pressure. Okay, that is your P. So just put up the values. P1 is 3 into 10 to the power 4. V is 0.2 plus P2 is 9 into 10 to the power 4 and V2 is 0.1 equals, P is now common because the pressure will become same once the wall is opened. So 0.2 plus 0.1. From here, you do the calculations and get the answer as 5 into 10 to the power 4 pascals. Okay, now state what is meant by a transverse wave. So, for example, you have a rope and the wave is moving this way and your rope is moving up and down, but the wave is moving right. What does it mean? rope is your medium, and the wave is moving forward. So you will say that those waves in which medium vibrates or oscillates perpendicular to the direction of wave. A transverse wave is traveling to the right on the string. The string shows at one particular time the variation of the displacement y with distance x along the string. 2 points P and Q on the string have been marked. Okay, P and Q, yeah, I can see that. Explain whether P or Q has the greater acceleration. So, very important question. Actually, this graph shows SHM. Okay, this graph shows SHM, which is called simple harmonic motion. Shows simple harmonic motion. And for simple harmonic motion, we know that acceleration is directly proportional to displacement from mean position, but always in opposite direction. Acceleration and displacement are directly proportional to each other, but their direction is opposite. So this is your mean position, and this is your extreme position. And at extreme position, you also always know that the displacement is max. At extreme position, displacement is zero at mean position. So what does it mean? So acceleration is also max at extreme position since a is directly proportional to x but in opposite direction, and a is zero at mean position for the same reason. So we have a greater acceleration at p. Okay. Okay. The speed of a wave is 62 meter per second. Calculate the period of the wave, giving your answer to the correct number of significant figures. So, what is actually the uh, speed relationship, which is F v equals F lambda? And from here, we can put this out. So, we have the speed, and we can get the wavelength, and we can find out the time period, right? So the wavelength is lambda over 62. Now you need to find out the wavelength. You can see that this is a displacement versus time graph. Okay, this is displacement, this is displacement, and this kind of graph always gives you wavelength, not time. Okay, remember, if you have a displacement time graph, it will give you time period, not wavelength. So, excuse me, this is your centimeter. So 4 centimeter, and it is starting from zero, like crest, and another crest is coming up at around 1.25, I believe, right? Yeah. So it is, just let me confirm it. It's one. This is, okay. So this is one, and this is 1.2, 1.4, 1.6, 1.8. 1.2. So this is 1.2. Okay. So 1.2 meters. On the x-axis we have meter. Yeah, we have meter. So 1.2 over 62. So answer is, let me do it. 1.2 divided by 62. 0.019. That is about 2. Okay. Calculate the average speed of P during one complete oscillation. So for one complete oscillation, you can see that the distance covered is given by this. So you start first of all here. This is like 4 centimeter. Then you go down 4 centimeter. Then you move up 4 centimeter, and then you move up again 4 centimeter. So that is the distance you traveled in one complete oscillation. Okay, that is actually 16 centimeter, because for the average speed you always have average distance over average time. Okay, so average distance is 0.16 and average time is 1.9 into 10 to the power minus 2 as calculated before. And finally the answer is 0.16, 1.9. So its answer is 8.42 meter per second. Okay, the string is now stretched between an oscillator and a fixed point. When the oscillator is set to a frequency of 120 Hz, the standing waves shown in the diagram is observed on the string. Draw the standing wave that would be observed on the string when the oscillator is set to frequency of 180 Hz. So it's obvious that 120 Hz is showing you the 2 loops, so 180 Hz will be showing you the 3 loops, right? Or in other words, you can see that F2 equals to F1, because this is the relationship of the harmonics when you have closed ends. Okay, so F2 equals to F1, and F2 is 120 equals to F1. And from here, the frequency for one harmonic is 60 Hertz. So for 3 harmonics, of course, you are going to have this thing. All right. Not 2, but 3. Okay. Make sure you make them correctly, otherwise they will not award you the marks. Okay. Okay, I think this way is much better. Okay. You have to keep them uniform, not different from each other, otherwise they can reduce your marks. Okay, physicists and engineers study simple harmonic oscillators even though most oscillations are not simple harmonic. Suggest why. So In the real world, the all systems in the real world, the systems are actually resembling the simple harmonic motion for places where your damping is not that much. Okay, so in real world, where damping means air resistance or the losses in the oscillations, the frictional losses in the oscillations. If your damping is not high enough or it's like very small, your the real systems actually resembles, behave like simple harmonic systems. All right. Okay, so question number 4. Two resistors X and Y are connected in series to a cell of EMF E and negligible internal resistance. The resistance of X and Y are constant. The power dissipated in X is greater than that in Y. State and explain how the resistance of X compares with resistance of Y. Since the circuit is connected in series, you say that in series I is same. So when I is same, what will be your power dissipation? Your power dissipation will be P equals I square R, right? Now, if it is eating more of the power, since I is same, so you can write that P is directly to R, which shows R is greater than, because for example from the top it's coming 10 watts and it is eating 3 watts and it is eating 7 watts and they're asking you why is it so. So it's right, the answer that the resistance of X is more, so power dissipation is more, therefore it is eating more of the power. Okay, X and Y are now connected in parallel to the same cell. State and explain which resistor has a greater power dissipation now. So again, if it is eating like 10 and they're now asking which one will be having more, so you need to know that in parallel voltage is same. So when voltage is remaining same in parallel, so we will say that this is opposite to that. So now since Rx is greater than Ry, so power dissipation in X is less than power dissipation in Y. Therefore, therefore, power dissipation is more in Y, in resistor Y. I hope you understand that. A lamp Z and resistor R have the IV characteristics shown in the graph. Calculate the resistance R. Okay. So how can you calculate the resistance R? You can calculate it using the gradient of the graph. So if I take the gradient, I'll just take it up as that is my final point. 40, 45, 50, 55. Okay. So let's take this point. Okay. And this one. This is 50. and 50 milliamperes. This is 50 milliamperes, and this is volts. And the gradient here is going to be rise over run. Rise is I and V. So it's 50 into 10 raised to the power minus 3 over V. And from here, the answer is 6.25 into 10 raised to the power minus 3. And we know that R is equals to V over I, but the gradient is I over V. So it means if we do that, now gradient is 6.25 into 10 raised to the power minus 3. And if we inverse it like this, it will give us the resistance, because V over I means 1 over gradient. Okay, so 1 over gradient equals resistance equals 1 over 6.25 into 10 raised to the power minus 3. And from here, your answer is 160 ohms. R and Z are connected in series to a cell of EMF 12 volts and negligible internal resistances there. Determine using the graph the power dissipated in lamp Z. It is a good question. And you need to be a little bit careful that if the 12 volt is coming from the top, it means this and this voltage should be equals to 12, right? According to Kirchhoff's voltage law. So you have to find out a combination from the graph that where the voltage of R and where the voltage of Z are equals to 12, equals to 12. Okay, so let's go to the graph and see. For example, if I talk about R's value here is 8, and for the same point, if I take a look here, for Z is it's 4, you can see, right? It's 4. So that is an ideal point, I believe, for RZ, like VZ, sorry. Let me change the color. So that is your VC and that is your VR. And VR is 8 and VZ is 4. So the sum of both is actually, same. And at 4 volts, what is the value of current? 50 milliamperes. Don't forget that. Okay. And it is for the bulb or the filament. So you just go back and just write from KVL and from the graph. You will write that uh, I equals 50 into 10 raised to the power minus 3 amperes for lamp VC at 4 volts, and R equals R, we need to find that, right? So V is R, V for R is 8 volts from the graph. Okay, and both have the same current, and I equals, right? So now power dissipation is simply for lamp, power dissipation is V equals V into I. So the power voltage is 4 and the current is 10 raised to the power 3 for lump. From the graph, we have seen that. And the answer is going to be 0.2 watts. Okay. Oh, where does it go? Okay, question number 5. The binding energy of the stable nuclide xenon is 1.105 giga electron volts. Outline what is binding energy. So binding energy is actually that amount of energy which is required to hold all the nucleons together, because you know that there is a nucleus and there are so many protons sitting together because they repel each other, right? They repel each other, but still they're inside. So who is holding them together? There is a binding force between them of the nucleons together, along with strong nuclear force. Okay, so we say that it is the amount of energy that holds the nucleons together, or inversely, we say that it is the amount of energy or minimum energy required to separate the nucleons. It's vice versa. You can write any of them. Any of them you can write. Minimum energy required to separate nucleons. So nucleons means protons and neutrons, okay, of a nucleus. Calculate in gigaelectron volt per c square the mass of the nucleus of xenon. So this c square is actually the speed of light. And you should know that E equals mc square, right? So we need to find out simply the mass. When we calculate the mass, it will be E over c square, right? And the energy is given in gigaelectron volts. You can see 1.105. Okay, so you will just write binding energy is 1.105 giga electron volts, right? So delta M is binding energy over c squared. So from 1.105 GeV over c square, right? Now you need to just find out the mass effect. And for the mass effect, what you need to do, you need to do delta M equals mass of all protons in xenon plus mass of all neutrons in xenon minus mass of full xenon atom. Okay. When we do that, how many protons are there in xenon? 54. And what is the mass of one proton? So mass of one proton is actually 0.938 GeV over c squared. It's actually MeV, so 938 MeV is actually the mass of proton, but when we convert it into GeV, it's 0.938 plus how many neutrons are there? So neutrons are actually 131 minus 54, and you will get it as 131 77. So 71, oh sorry, 77 into mass of the neutron, which is 0.940 GeV over percent T square. And finally, you will you will find out the mass of the xenon. from here. Okay, this is what actually we need to find that out. Not the mass effect. So mass effect we already have. Okay, and the mass effect is going to be, we are just taking this here and we are putting it here. And finally, the mass of the xenon nucleus. Mass of xenon nucleus is, so just multiply them and get the answer like 50.33 plus 72.38 minus 1.105. So the answer is 121.6 GeV over C square. Okay. Xenon and xenon are two isotopes of xenon. Okay. One is 131 and one is 133. Outline what is meant by isotopes. So you can easily see that their proton number is different, but their mass number is not same. I mean, their proton number is same, but their mass number is not same. So you can say the atoms of a same the atoms of the same element having the same number of protons but different number of neutrons. Okay. And because of different number of neutrons, you also have different mass number, or different mass number, you can also say. So xenon 13354 is radioactive. Okay. Suggest how binding energy per nucleon for 131 compares with that of 13354. So of course, Xc is radioactive, so it means it is unstable, while Xe 13154 is stable. So which one is stable always? That means Xe 13154 has more binding energy per nucleon, therefore it is more stable. Okay. More than X13354 because it is stable and the other one is not stable. Okay, determine the number of up quarks in a nucleus of 131 xenon. So how many protons are there? One proton has how many quarks? One proton is actually having this much structure. So you say two quarks. Okay. And how many protons are there in xenon? 54 protons. So 54 protons means 2 into 54 equals 108 quarks. And what about neutrons? You have 77 neutrons. First of all, you will write how many one neutron has UDD structure. So just one quark. So 77 protons, sorry, 77 neutrons has 77 quarks. Okay. Total xenon quarks. Total xenon quarks 77 plus 108, and it will be a total of 185 quarks. Okay. The graph shows the variation with time of the activity of pure sample of xenon 13354. Estimate the half-life of xenon. So estimate half-life means here you have 9 into 10 raised to the power 7 becquerel of the activity. And where do you have 4.5? So 4.5 is exactly this point. So here you can see it is lying exactly 4.5, 5.5, 5.25. 5.25 or 5.3, you can say 5.3 days or 5.25 days, whatever. So from graph, it is 5.25 to 5.3 days. Question number 6. Describe the energy transfers taking place in a wind generator. So in a wind generator, the way the wind is blowing, so it means a kinetic energy of air will be there. Kinetic energy of air. And while it will come and hit the blades of the wind turbine, the wind turbine blades will move, and any energy that you see as moving energy is actually a mechanical energy. For example, the fan is moving, mechanical, but the electrons are moving, you cannot see, right? But for the winds, you can easily see the mechanical energy, right? Mechanical energy. And that mechanical energy, when the wind turbine blades move mechanically, they actually move the shaft in the generator, and inside the electrical energy is produced. Okay? The maximum power that can be extracted from the wind generator is given by P equals half rho A V cube. State one assumption made in driving this equation. So we say that the wind is coming like a laminar flow. Okay, wind flow is laminar, and the air is incompressible. You can also say, all right, or the wind is incompressible. So what do I mean by saying wind is incompressible? Have you ever seen that the the tires of a vehicle have the air inside? So if the air can be compressed, do you think we will be able to run the cars? Actually, it's not. We can just push them together to a certain limit. And as soon as air comes out of the tire, it expands back. It means it cannot be compressed, right? If the air can be compressed like any foam or anything, we would never be able to drive the cars. Okay, because the air will be compressed inside the tires. The following data are available for the wind generator: blade density, okay, wear and incident, and wind leaving after. Determine the maximum power stating the correct unit prescribed by the wind generator. So it's an easy question. They have given you the power formula, which is this. Just put in the data. P equals 1 over 2 rho A V cube. Okay. And V cube is actually the speed, and the incoming and outgoing. You just need to take the difference between the two. And that's it. P equals 1 by 2. Rho is 1 by 2. A is, you don't know, A is actually pi r square. And the speed is actually the difference between the incident and the living speed. Okay, so so it's actually the difference now. 1 by 2, 1.2 pi, and the radius is 2.5 square. In is 6.8 cube minus out is 2.6 cube. Okay, oh, not separately, it's just inside. Okay, so let me calculate the value. Yeah, answer is not coming correct. It means I have a mistake, and the mistake is actually this one. I have to take the speeds separate from. Okay, so when we do the separate calculations, we do 0.5 into 1.2 into 5, 2.5 r square multiplied by 6.8 cube minus 2.6 cube, and the answer is 3686. About that, 3686 watts. Okay, so that is the end of your paper 2. I hope you enjoyed it, and if you have any queries or if you want any help in physics, please reach me out. See you in the next video. Up till then, it's goodbye, and don't forget to like and subscribe. Okay, bye bye. Take care.